We're going to look at how segments relate when we have two chords that intersect inside a circle and also outside of a circle. If you have chords that intersect inside a circle, you can do A times B equals C times D. And the reason for that is because if you make this into two triangles, these two triangles are similar because these angles are congruent because they're vertical angles, and these two angles are congruent because they open up to the same arc. They have the same intercepted arc, which means A to D equals C to B because those are corresponding parts. And then if you cross multiply, you have A times B equals C times D. If you have intersecting chords outside of a circle, you do the outside segment times the whole segment. So outside times the whole equals the outside segment times the whole segment. So we have A times, not A times B, it's A plus B, equals C times C plus D. Same with if it looks a little bit different. You still have outside A times the whole thing, A plus B, equals outside C times the whole thing, which is still just C. A few examples. In the first one, we have an intersection that's inside the circle, which means we can do x times 3 equals 6 times 2, and x equals 4. The next two, both chords intersect outside the circle, so we want to use the other formula, the outside times whole equals outside times whole. So we can do outside for this one is 5 times whole is 5 equals outside is 2 times the whole thing is 2 plus x. So that's 25 equals 4 plus 2x. Subtract 4, 21 equals 2x. So x equals 21 halves. And then the next one, outside times whole. So 6 times 6 plus 8 equals outside 7 times the whole thing, x plus 7. So that's 6 times 14 equals 7x plus 49. 6 times 14 is 84. And then you can subtract 49 from both sides. You get 35 equals 7x. Divide both sides by 7, and x equals 5.